And so I'm super pleased to welcome Melissa Bossman. Melissa Bossman is the Dredging program manager for the U.S. Army Corps of Engineers Detroit District. Melissa graduated from Wayne State University with a BS and an MS in civil engineering. And Melissa started with the Army Corps of Engineers in 2009 as a civil engineer. From 2009 to 2014, Melissa held positions working in hydraulics, project engineer in the Grand Haven area office, regulatory and construction administration sections, lots of experience. And in 2014, Melissa started in the operations office and has spent that time as a project manager, and currently, as I said, is the Dredging program manager. So Melissa, the floor is now yours.
All right, good morning. Can everybody hear me?
Yes, we can.
All right. Well, thank you so much for having me. Again, my name is Melissa Bossman. I'm the Dredging Program Manager for the Detroit District's Army Corps of Engineers. Today, I'm going to provide a brief overview of the Great Lakes Navigation System and a high-level view of dredge material management and beneficial use of dredge material. Then we'll open it up for questions following the presentation as time allows. Next slide, please. Great. The Great Lakes Navigation is really a navigation system that's operated and maintained by the Great Lakes Navigation Team, which includes representatives from the Detroit, Chicago, and Buffalo districts, and our stakeholders. Our stakeholders' support identifying beneficial uses for the dredge material is critical to the operation maintenance of the Great Lakes Navigation System. We cannot dredge the projects if we don't have suitable placement sites for the dredge material. So the Great Lakes Navigation System consists of 140 federal harbors on the Great Lakes and 4 connecting channels. Those connecting channels are the St. Mary's River, Detroit River, St. Clair River, and the channels of Lake St. Clair. And then within the system, there are also 3 locks, the Sioux Lock, the Chicago Lock, and the Black Rock Lock in Buffalo, New York. So in 2005, the Great Lakes Navigation Team was formed for the purpose of developing strategies and plans for the Great Lakes Navigation System to meet current and future needs using a system-wide approach of reducing risk and providing optimal reliability. Next slide, please. Navigation waterways allow for heavy bulk commodities to be delivered economically from source to destination. Throughout American history, industry is built up along the lakes where they can take delivery of bulk commodities. The Great Lakes model is based on waterborne commerce delivering commodities to industry. Other modes are not available and/or they're not economical. The coastal ports compete with each other for trade. If one port cannot accommodate the traffic, the cargo can easily switch to the next port because this is container traffic to be loaded onto trucks and rail and transported away from the port. However, in the Great Lakes, commodities can't easily be moved to the next harbor because power plants and manufacturing plants are located at those destination harbors. In most cases, rail is not available there. The high tonnage harbors are dependent on low and moderate tonnage harbors. So it's important to maintain all of the federal harbors. Next slide, please. The Great Lakes Navigation System is a nonlinear, interdependent system that carries bulk commodities from source locations to users at destination ports. The vast majority of the traffic, about 95% of the traffic, stays within the Great Lakes Navigation System, exchanging commodities between U.S. ports or U.S. and Canadian ports. Alternatively, ocean coastal ports, they primarily trade in containerized commodities, importing from and exporting to ports overseas. Another key difference between ocean ports and the Great Lakes ports is that ocean coastal ports compete with each other for trade. If one port, again, can't accommodate the traffic, the cargo can easily switch to the next port. So, you know, again, in the Great Lakes, the commodities cannot be easily moved to the next harbor because the users, such as the power plants and manufactured plants, are located at the destination port. So I guess in summary, the Great Lakes Navigation System saves almost $4 billion per year over the next mode of transportation. So closing a harbor on the Great Lakes moves those commodities to alternate modes of transportation, so rail or truck, at significant increased cost to the shippers and adverse impacts to emissions, safety, and economic damages from increased accidents. Please note that alternate modes are not feasible for all commodities or delivery points. Next slide, please. So within the Great Lakes Navigation System, the Detroit District operates and maintains 84 of the 140 federal projects, which does include deep and shallow draft harbors and connecting channels. We also operate and maintain 9 dredge material disposal facilities in the Detroit District. The Detroit District covers all of Michigan, the Lake Superior coastline projects in Minnesota and Wisconsin, and Menominee Harbor, which separates Michigan and Wisconsin. Within the Detroit District, there are 4 field offices, and the area responsibility for each office is shown on this map. So starting at the top of the map, the Duluth Project Office boundary is shown in peach. The Sioux Project Office is in purple. The Grand Haven Project Office is in green, and the Detroit Project Office is shown in yellow. Next slide, please. So why does the U.S. Army Corps of Engineers dredge? I think I pretty well hit on the importance of it on the previous slides, but the U.S. Army Corps of Engineers has been responsible for the development and maintenance of navigable waterways in the United States since 1824, when congressional authorization was received to remove sandbars and snags from major navigable rivers. Today, the Army Corps of Engineers navigation goal is to provide safe, reliable, effective, and environmentally sustainable waterborne transportation system for movement of commerce, national security needs, and recreation. Navigable inland and coastal waterways, ports, and harbors are critical to the United States as a major means of commercial transportation and as an integral part of national defense. Next slide, please. So, as you can see again from the previous slides, that navigation is really important. It's really a key Corps of Engineers mission area. So maintaining our federal channel infrastructure is essential for strengthening the nation's economy, creating jobs, reducing risks, and bolstering our long-term global competitiveness and national security. Next slide, please. So the annual sediment load to the Great Lakes ports and harbors is approximately 3.3 million cubic yards of material each year. So if less than 3.3 million cubic yards is dredged in a given year, the backlog will continue to grow. Dredging is required annually to keep pace with the sediment inflow at the Great Lakes federal harbors and channels. Each year, $50 million is needed to keep up with that annual dredging requirement. When USACE dredges less than that 3.3 million cubic yards, the backlog of the material grows. Conversely, when USACE is able to dredge more than 3.3 million cubic yards in any given year, the backlog will decrease. The dredging on the Great Lakes suffered for many years due to limited operations and maintenance funding and lower water levels. However, since 2014, funding for dredging has been steady and above the minimum funding available to reduce that backlog. Backlog was reduced from a high of about 18 million cubic yards in 2014 down to approximately 11.6 million cubic yards at the end of 2019. Since then, backlog has once again increased due to high pricing that made contracts unawardable and the lack of dredge material placement locations in some of the harbors. They also contributed to that backlog. Dredging backlog in the Great Lakes was 13.6 million cubic yards at the end of 2022. So we're generally seeing an increase in the cost per cubic yard for dredging from $7 a cubic yard all the way up to $70 per cubic yard. And that higher $70 cubic yard price is really driven by projects where the material is being required to go to upland facilities. We've seen that mostly happen in Ohio. And And when we have to place that material in upland facilities, that requires double handling the material. And this cost is not sustainable in the Great Lakes system to effectively dredge our harbors. The cost of dredging projects is influenced by many factors, though. These factors include environmental requirements to ensure proper disposal of material, avoiding disturbances to fish spawning, and negative impacts to other species. Small and remote harbors often require large mob-demob fees and low productivity rates. We also have a short dredging season on the Great Lakes. We have winter shutdowns, spring spawning, fall waves and winds, making the outer harbors unsafe to dredge. So it really leaves most of that work to be performed in the summer months, which is also during the peak tourism season. Additionally, some types of our placement can require multiple handling of the material, such as transferring that material from a barge to a truck, and then the trucks have to transport that material into a disposal facility. Next slide, please. So on the previous slide, I mentioned that we need to dredge just over 3 million cubic yards per year to keep the navigation system open to facilitate navigation. However, before we can even dredge, we must have suitable placement sites identified and coordinated for placement of that dredge material. Dredge material management is one of our biggest and most important challenges. If we don't have a suitable placement site for the material, we cannot dredge that harbor. And closing a harbor on the Great Lakes moves those commodities to alternate modes of transportation, such as rail and truck, at significant increased cost to the shippers and adverse impacts to emission safety and economic damages from increased accidents. Next slide, please. So prior to 1970, nearly all of our dredge material was placed in the open waters of the lakes. However, in 1970, Congress passed the Rivers and Harbor and Flood Control Act that specifically authorized the USACE to construct, operate, and maintain spoil disposal facilities on the Great Lakes for confinement of contaminated dredge material. Most existing facilities were constructed in the late 70s. There are currently 20 active disposal facilities on the Great Lakes, which are more than 80% full now. So as disposal facilities are nearing capacity and the sediment is becoming less contaminated or cleaner, the Corps is looking to develop more sustainable methods for managing the dredge material by partnering with local entities to find beneficial uses for the dredge material. The dredge material management is not just a challenge in the Great Lakes, it's a nationwide challenge. Next slide, please. So there are many challenges with the dredge material management. As I mentioned on the previous slide, CDS constructed in the 70s on the Great Lakes are more than 80% full, and new CDS are very costly to construct. There's also growing resistance and opposition to open water placement in some states. However, the good news is that the shoal material is getting cleaner and the material is a valuable resource. There's a lot of opportunities to beneficially use the clean sand, but it's been a challenge finding projects that require fine and silty material. The reality is, again, that if we can't find suitable placement sites for the dredge material, we're unable to maintain the harbor. Next slide, please. Dredge material from the Great Lakes Navigation System harbors and channels are typically managed in one of four methods: either open water placement, beach nourishment, which we also call nearshore placement, CDF confinement, or upland placement. This figure shows dredge material placement methods, on the Great Lakes Navigation System commercial harbors based on dredging that has occurred between 2011 and 2021. So again, this is for our commercial harbors or our deep draft harbors. This doesn't include all of the recreational harbors and shallow draft that we need to maintain. Some of the harbors require more than one placement method. The method really depends on the area of the harbor that we're dredging and the sediment characteristics. The chemical, physical, and biological analysis of the material are performed prior to dredging to determine the suitable placement method or methods. Nearshore placement includes beach nourishment, shallow water placement for habitat creation, in-water capping of contaminated sediment, etc. Where upland placement includes beneficial uses on land for habitat development, construction sites, agriculture, recreation, parks, land remediation, and unrestricted fill material. Next slide, please. All right, the federal standard. So the federal standard is defined as the dredge material disposal alternative or alternatives identified by the Corps, which represents the least costly alternatives consistent with sound engineering practices and meeting the environmental standards established by the 404B1 evaluation process or ocean dumping criteria. In practice, the federal standard determines which of the three general approaches for dredge material management can be used for dredging at a given site. The least cost, environmentally acceptable alternative that satisfies the federal standard is the base plan. The determination of the federal standard and corresponding base plan is a critical step in the project decision-making process. The base plan defines the benchmark for discussions with the states and the financial limits of the federal participation in the dredge material placement. In 1999, the DMMP for the Blue Superior Harbor was approved, and it established the base plan for the Blue Superior Harbor dredge material. The base plan included use of a combination of three major segments, first one being beach nourishment, the second one continued use of the Erie Pier CDF for contaminated material, and three, placing dredge material in the deep holes within Duluth Superior Harbor. Implementation of the strategy would provide for capacity exceeding 20 years. Next slide, please. Section 125, awarded 2020, renews the congressional commitment to beneficially use dredge material and is the policy of the United States for the Corps of Engineers to maximize the beneficial reuse of suitable dredge material obtained from the construction or operations and maintenance of water resource development projects. There are really four sub-paragraphs to Section 125 of awarded 2020. Subparagraph A has two main parts. The first part requires the Corps to calculate the economic and environmental benefits of the beneficial use of dredge material when calculating that federal standard. This does not change the definition of the federal standard. It's still the dredge material disposal alternatives, which represent the least costly alternative consistent with sound engineering practices and meeting the environmental standards established by the 404B1 evaluation process. However, now we will also consider the economic and environmental benefits of the beneficial use of dredge material when calculating that federal standard. The second part of subparagraph A allows the Corps to use operations and maintenance funds to pay the federal portion of the cost share for the incremental cost above the federal standard. Subparagraph B increases the number of beneficial use of dredge material demonstration projects to 35 projects. Subparagraph C directs the Corps to develop 5-year regional dredge material management plans. And finally, subparagraph D emphasizes greater coordination across the Corps dredging contracts. So if there is a need for USACE to dredge an authorized channel, the operational strategy should inherently include beneficial use placement options. Equally, if there's a need for sediment, gravel, or rock material to implement a project, beneficial use from dredging operations within the authorized channels should be considered as a source in planning and execution strategy. Next slide, please. So on the previous slide, I mentioned that the first part of subparagraph A requires the Corps to calculate the economic and environmental benefits of the beneficial use of dredge material when calculating the federal standard. We must do these things in compliance with applicable laws and regulations, including the federal standard for dredge material disposal or placement. However, a proper analysis of the total life cycle costs of dredging and placement, as well as the full benefits, will result in an accurate determination of the federal standard. In other words, we need to use the leverage of the apple to beneficially use material rather than letting the orange tip the scale. There is no one equation that we have that will, give us, those benefits. It'll depend really on where we're placing and the benefits of that placement. But we are encouraged to be creative. Next slide, please. So U.S. Army Corps of Engineers Chief of Engineers Beneficial Use of Dredged Material Command Policy Notice was issued in January 2023 and outlines the vision for expanding the beneficial use of dredged material program. So the Corps of Engineers historically uses 30 to 40% of the sediments derived from the navigation mission for beneficial purposes. The Chief established a goal for the Corps of Engineers to advance the practice of beneficial use of dredged material to 70% by the year 2030. So it's going to be a huge lift, going from 30 to 40% to 70% in 6 years. In the notice, the Chief of Engineers reiterates that dredged material is a valued resource that is not to be wasted, but instead used for benefits to the ecosystem, economy, and to deliver the USACE mission more effectively and efficiently across our portfolio of navigation, flood risk management, and aquatic ecosystem restoration projects. Achieving our vision will require purposeful documentation and an innovative pursuit, both internally and externally, with our partners and stakeholders. We will need to leverage available solutions, strategies, and tools to maximum extent practical, while developing and applying new approaches and technologies to address the associated engineering challenges. This is really a cultural shift in the way that we think about our dredged material. We do recognize that our dredged material is a valuable resource and it should be treated as such. Next slide, please. Here are some examples of beneficial uses for dredged material. So habitat development would be wetlands, upland, island, aquatic, including migratory and nesting by waterbird, shoreline, waterfall, and other groups. The interstate island and piping plover projects are examples of where we were able to beneficially use dredged material from the Duluth Superior Harbor to restore habitat for bird nesting. Beach nourishment is the primary beneficial use of dredged material for most of our harbors on Lake Michigan in the Detroit area, the Detroit District area responsibility. Parks and recreation, so commercial and non-commercial. We've used dredged material from Ashland Harbor for park creation along the water. That would be one example. And then I guess following that would be an example of where we used dredged material. We provided that to one of our stakeholders, and they were able to mix it with leaves to make topsoil and sell that topsoil. For strip mine reclamation and solid waste management, we're doing this with material from the Erie Pier CDF. So the dredged material is used as a cap at landfills and for mineland reclamation. Examples of shoreline stabilization and erosion control would be where we've beneficially used dredged material from the Duluth Superior Harbor to temporarily restore the shoreline along Minnesota Point in Duluth, Minnesota. And then finally, an example of construction industrial use that comes to mind is in Manistee Harbor. Our dredged material is used by the city for infrastructure projects such as pipe bedding, material for road construction, and top dressing embankments on their construction projects. So those are some examples of beneficial uses of dredged material, how the Detroit District has implemented beneficial use. Next slide, please. All right. So here are some dredged material management strategies that the Corps is and will continue to employ to maximize the beneficial use of dredged material. So we are extending CDF life through fill management and facility adaptation, such as raising perimeter dikes and reworking material within the facility to create additional capacity. We're aggressively pursuing opportunities for beneficial use of dredged material including in some cases removing material from CDS for beneficial uses. And we hope to continue to expand on that, find more beneficial uses for that material in the CDS, because it's just extremely costly to even construct a new CDF. So we really need to figure out how to get that material out of the CDF and then continue using the CDS when we need to. So we're also continuing to foster strategic partnerships with state agencies and stakeholders. We're engaging state agencies and other partners and stakeholders in developing innovative long-term solutions to dredge material management challenges. State agencies are a key partner in dredge material management, playing a role from the regulatory perspective and sometimes non-federal sponsor support. We were able to beneficially use over 1.2 million cubic yards of dredge material by fostering partnerships with the U.S. EPA and some of our local and state agencies in the Duluth Superior Harbor AOC. So we were able to leverage funding for projects supporting other environmental goals and navigation benefits to beneficially use that dredge material. We're leveraging research and development to explore technologies for dredge material management and other technologies. So we really want to see what technologies and processes exist and can be developed to condition material in CDFs for potential reuse for habitat restoration, brownfield cover, landfill cover, and other other efforts. Next slide, please. All right, already to the end. So I guess in closing, I'd like to say that from the Corps of Engineers, we really appreciate the continued support from the HTAC, the Sea Grant, Blue Seaway Port Authority, our local, state, and federal partners. And we are looking forward to further engagement on the beneficial use of dredge material. So that's all I have today. I guess, Kelsey, if you want to open it up to questions, if there's time.
Yeah, there's time, Melissa. Thank you so much for the presentation. So I should have said before Melissa started that for the virtual participants, we have the Q&A feature enabled. So you can type your questions into the Q&A box, and then Madison will read those questions off for Melissa to be able to answer them. So that's the way that we're going to work the virtual Q&A. Since I didn't say that prior to the start of the presentation, I imagine we probably don't have questions yet, but virtual participants, please do type your questions into the Q&A, and we can start with Q&A from the room. So I'll stand up. Anyone with questions for Melissa? Yeah, Gary.
Have you tried to use any fraction of the material for fracking mining?
Did you hear that, Melissa?
I heard the first part of it, using a fraction of the material. Is it for fracking?
For frac sand.
I mean, specific to the Detroit district, I'm not aware of any. That is interesting. That would be something interesting to look, expand on, I guess, or look closer at. I can't speak nationwide what other core districts are doing, but certainly we'll note that as something that we could work with our R&D group on.
Other questions, Jeff?
Hey, Melissa, Jeff Stallenberg from the Duluth Seaway Port Authority. You mentioned the 2020 WRDA that provides authorization to consider the economic benefit of beneficial use projects. I know the Corps was working on guidance for how to calculate that economic benefit. Is there any update on that piece?
Yeah, thank you, Jeff. It's a great question. So we haven't received any new updated implementation guidance on that. However, I was on a call last week with our headquarters, and they are currently developing that guidance. So I would expect to see it here in, maybe the next year, if not sooner.
And then to follow up, one of the things that we're doing later this afternoon for those who are in person here today is we're bringing in an environmental economist to talk about ecosystem services valuation methods that are used commonly. And so our goal with that is to just give you all some knowledge about how that's typically done, and then maybe talk about some next steps for Port of Duluth Superior and how we can apply some of those methods to beneficial use projects. Other questions? Do we have questions virtually? Yes.
We do have some questions virtually. So the first question is kind of building off Jeff's previous question on methodology for calculating economic and environmental benefits of the beneficial use of dredge material. The question is, if so, will these benefits be given a monetary value? And the add-on question there is, when getting to the least cost alternative, is this solely based on cost, or is it a benefit cost ratio? And Melissa, I can repeat that too if you need me to.
I think I got it, but thank you. So I think that the first part of the question was addressed kind of when we addressed Jeff's, that there is more guidance coming on how we can, calculate that federal standard when we're considering the benefits. And that is forthcoming. It will come. They're just working on it right now. And then maybe if you could repeat that second part of the question.
Yeah, the second part is, when getting to that least cost alternative, is it solely based on cost, or is it a benefit cost ratio?
I know it's not solely on cost. We need to be looking at the benefits that beneficial use of dredge material provides. So I would say, it'd be closer to that benefit cost ratio than just focusing on the cost of placing that material.
And then we do have one more online question, or they're coming in. So we have two more online questions.
Coming in.
So where would we find the geotechnical characteristics of the dredge materials, such as grain size, slump, etc.?
So we routinely sample the material that's in the harbor within our navigation channels that we know we need to dredge. So we're routinely sampling that and analyzing that material. So we get a full report of the grain size, the biological, the physical characteristics of that material. And we work through the process of evaluating that material to determine what type of beneficial use we could use that material for.
Okay, two more online questions. This one's kind of a follow-up, just so we're aware. The St. Paul District of the Army Corps of Engineers hosted a workshop last week, along with Engineering Research and Development Center, the ERDC. They have been working on a beneficial use comparison or beneficial use comprehensive benefit tool to help quantify the benefits in justifying a placement option. And then the person clarifies environmental benefits, they should say. So just a note there. I don't know, Melissa, if you have any follow-up there from the St. Paul District, but just a comment and connection to the work presented.
Appreciate that. Thank you.
And then one more question. As part of the 2030 goal to beneficially use 70% of dredge material, was additional funding included to allow the COE and/or partners to facilitate scoping, design, and implementation of these projects, as these efforts likely exceed basic O&M funding?
So unfortunately, I can't really speak to the funding side of this. I do know that, with the 5-year regional DMMP, that's in Section 125 Award of 2020. We do get, we do submit, capability or a budget request to fill those 5-year DMMPs out. And that's for really any project that we're going to be dredging in the next 5 years. We need to consider a whole suite of opportunities for beneficially using that material through the DMMP process. So the 20-year dredge material management process. We submit budget requests to get funded for that DMMP, and that is where we will kind of really go into a deeper evaluation of those opportunities for beneficial use to see where we can use that material to beneficially use it.
Thanks, Melissa. We've got one more question. This is an easy one. What is the location of the photo on this question slide?
I believe this is in Grand Haven. So there's a state park right there, and it's state or county, I don't remember. I think it's state, but yeah, we were placing dredge material out there. We shut down for a little, a short period of time, and as you can see, they were all too eager to get out there on that new sand and recreate.
Okay, so we have 3 more minutes. We can take questions in the room. I'll get to you next, but since Willis has had his hand up, I'll go.
Yeah, kind of following up on the string of questions from Jeff, and that is that, did the new provision of WRDA allow for exception from the least cost alternative of disposal to allow for beneficial uses that might be more expensive? Is that my understanding of that clause?
Yeah, so thank you, Lois. So it does, so the federal standard will still be calculated, and we still must adhere to the federal standard, the least costly placement option. However, now we can also include the benefits in that cost when we're in that calculation to determine the federal cost or the federal standard. I don't know if I answered that explicitly for you, Willis. We would still require a cost share above that federal standard base plan placement option. If, say, we knew that it was cheapest to put it on the beach, but say a stakeholder or an agency wanted us to go place it somewhere else that was more costly than that federal standard or base plan, they would have to cost share that incremental cost above the federal standard to place that material there.
Thank you.
You're welcome.
Okay, Gary, go ahead.
Hi, Melissa, Gary Glass here. I'm interested in your list of parameters that you've measured in the Duluth Superior Harbor for the product of dredge materials, particularly if you have numbers for lithium, so that battery potential could be looked at as a production in the future, and also for PFAS, so as a possible negative that we would want to avoid. If you have either of those parameters, lithium or PFAS, analyzed?
I would have to defer to our environmental section, who is not on the phone, unfortunately. I work with our environmental section and the sediment sampling, the analysis, and some of the NEPA stuff, but they're really the people who should be speaking about it, not me. Sorry, Gary.
Thank you.
Oh, yeah, it's something that we're just not, the PFAS question is something that we're just not prepared to talk about in the scope of this particular workshop. The lithium question is that's something that they'll have to just defer to their regulatory environmental folks. I think that, so Gary's interested in the potential beneficial use of lithium from dredge material for battery use. Okay, that's it for questions. And